Lesson: Designing effective test cases for AI models. Designing effective test cases for AI models is a critical skill for AI workflow and automation specialists. The ability to construct comprehensive test cases ensures that AI systems operate as intended, are robust, and can handle real-world data effectively. A test case for an AI model typically involves a set of inputs, execution conditions, and expected outcomes. The complexity of AI models, including their non-deterministic nature and dependency on vast amounts of data, makes this process unique compared to traditional software testing. The first step in designing effective test cases for AI models is understanding the model's purpose and architecture. This involves a thorough comprehension of the model's inputs, outputs, and the learning algorithm it employs. For instance, if the AI model is a neural network for image recognition, understanding the convolutional layers, pooling layers, and fully connected layers is crucial. This knowledge helps in identifying which aspects of the model are most susceptible to errors. Once the model's architecture is understood, the next step is defining the test objectives. These objectives should align with the model's intended use cases and performance metrics. For example, if the model is designed for fraud detection, the test objectives might include evaluating its accuracy, precision, recall, and F1 score on a dataset representative of real-world transactions. Defining clear objectives ensures that the test cases will provide meaningful insights into the model's performance. With the objectives in place, selecting appropriate datasets is paramount. The datasets should be diverse and accurately reflect the conditions the AI model will encounter in production. This includes considering edge cases, such as rare but critical scenarios. For instance, in a sentiment analysis model, test cases should include slang, sarcasm, and mixed sentiments to ensure the model's robustness. A study by Amershi et al. Highlights the importance of diverse datasets in capturing the full complexity of real-world scenarios, thereby improving model reliability. After dataset selection, the next step is designing the individual test cases. Each test case should specify the input data, the conditions under which the model is tested, and the expected output. For example, in a chatbot application, a test case might involve inputting a complex user query and expecting a coherent and contextually relevant response. Tools such as Jupyter Notebooks and Python's unit test library can be employed to automate this process, enabling the execution of multiple test cases efficiently. A crucial aspect of test case design is performance evaluation. This involves comparing the model's actual outputs with the expected outputs and quantifying the discrepancies. Metrics such as accuracy, precision, recall, and F1 score are commonly used for classification tasks, while mean squared error or root mean squared error might be used for regression tasks. Advanced tools like TensorFlow model analysis can be leveraged to perform detailed evaluations, providing insights into model behavior across different slices of data. Addressing the explainability and interpretability of AI models is another vital consideration. Test cases should assess whether the model's decisions can be understood and justified. Techniques like SHAP and LIME can be incorporated into test cases to provide insights into feature importance and model predictions. These tools not only help in validating the model's decisions, but also in identifying potential biases that might have crept into the model during training. Furthermore, continuous testing and monitoring are essential for maintaining the effectiveness of AI models over time. As new data becomes available, test cases should be updated and re-executed to ensure the model adapts to any changes in the underlying data distribution. This is particularly important in dynamic environments where data evolves rapidly. Frameworks like MLflow can assist in managing the lifecycle of machine learning models, including tracking and versioning test cases. Incorporating user feedback into the testing process can significantly enhance the quality of test cases. By analyzing user interactions with the AI system, test cases can be refined to better mimic real-world scenarios. This iterative process ensures that the model continues to meet user expectations and delivers optimal performance. Case studies in the literature emphasize the value of user feedback in improving AI systems, underscoring the importance of a user-centric approach to test case design. A practical example of these principles in action can be seen in the deployment of AI models for autonomous vehicles. Designing test cases for such models involves simulating various driving conditions, such as different weather conditions, road types, and traffic scenarios. The complexity of these scenarios necessitates the use of advanced simulation tools like Carla, which allows for the creation of realistic virtual environments to test the model's decision-making capabilities safely. Moreover, addressing ethical and fairness considerations is essential in the design of AI test cases. Test cases should evaluate whether the model performs equitably across different demographic groups and does not perpetuate biases. Techniques such as fairness-aware algorithms and bias detection tools can be integrated into the testing framework to ensure compliance with ethical standards. This ensures that the AI system is not only effective, but also responsible and trustworthy. In conclusion, designing effective test cases for AI models is an intricate process that requires a deep understanding of the model architecture, clear test objectives, diverse datasets, and robust evaluation metrics. The integration of advanced tools and frameworks, such as TMA SHAP and Carla, enhances the testing process by providing detailed insights into model performance and behavior. Continuous testing, user feedback, and ethical considerations further refine test cases, ensuring that AI models remain reliable, interpretable, and fair. By following these guidelines, AI workflow and automation specialists can develop test cases that not only validate the model's performance, but also contribute to the advancement of ethical and responsible AI.